சிடி வேல்யூ இல்லாம ரிப்போர்ட் வந்து அது இன்வாலிட்ன்றாங்க. அவன் சிடி வேல்யூ போடல.
சரி.
அப்ப என்னதான் அதுல கன்ஃபார்ம் பண்ண முடியும்?
இப்ப நம்ம கிளாஸ் டீச்சர்ஸ்லாம் அந்தந்த கிளாஸ் ரூமுக்கு போயிருவாங்க சார்.
அவங்கள எப்படி அந்த கிளாஸ் ரூம்ல இருக்க சொன்னா?
நம்ம ஃபுல்லா பிசிக்ஸ் ஸ்டாஃப் ரூம்ல இருப்போம்.
ஆமா ஆமா, மற்றவங்க பிசிக்ஸ் ஸ்டாஃபும். லிங்க் ஒன்று கொடுப்பாங்களா, அந்த லிங்க் நம்ம கனெக்ட் பண்ணிக்கணும்னு சொன்னாங்க.
லிங்க் வருதான், நான் 2-3 தடவை மெயில பார்த்தேன், ஒன்றும் காணும். ஆனிக்கு சார் லிங்க் தனியா வருமா?
ஸ்டாஃப் ரூம்லையும் சேர்த்து போட்டா கொஞ்சம் நம்ம கிளிக் பண்றது வசதியா இருக்கும். சரி.
Good afternoon, sir.
Good afternoon, நண்பா.
Sir?
Sir, sorry, sir.
சரி,
Dr.
நான் அவரை பார்த்துருக்கேன்.
Yes, sir.
அவரை பார்த்துருக்கேன். அந்த இது சர்டிஃபிகேட்
Yes, sir.
அதுக்கு பண்ணும்போது அந்த டிபார்ட்மெண்ட் போகும்போது எல்லாம் யாருக்கும் அவர்
அப்பதான் நீங்க அப்புறம் எழுதி ஸ்ரீரங்கம்.
அவரை சஜஸ்ட் பண்ணேன். இந்த மாதிரி என்னோட வாத்தியார் ஒருத்தர் தெஜஸ்வே படிச்சவர் சென்னையில் இருக்கிற டாக்டர் வி மசலாமணி.
எஸ் சார்.
அவர் மெட்டல் டிபார்ட்மெண்ட் அண்ணா யூனிவர்சிட்டியில் அவர் அந்த ஆனிவர்சரி வந்தார். அவர் தான் வந்து இந்த மாதிரி இதுக்கெல்லாம் வந்து கரெக்டான ஆதரவு பண்ணேன்.
இந்த லிங்க் இல்லை சார், உங்களோட பண்ணி சார். சார் சார் வந்துட்டாங்க சார்.
சார் உங்களுக்கு எது கம்ஃபர்டபுளா இருக்கும்?
உங்களுக்கு எந்த கம்ஃபர்டபுள்?
அடிக்கடி இங்க பக்கத்துல இருக்கிறதால
ஓகே சார். சார் இப்போ சார் வந்து எப்படி சார் உள்ள கொண்டு வருது? ஸ்பீக்கர் இல்ல சார்,
நாங்க வீட்டுல இருக்கோம்.
நாங்க வந்து சாரோட வீட்டுல இருக்கிறோம்.
நாங்க சாருடைய வீட்டுல இருக்கோம். இப்ப சாருக்கு நீங்க லிங்க் அனுப்புறீங்களான்னு
மாற்றி கொடுத்துருக்கேன்.
சார் மெயில் ஐடி
எஸ் வெயிட்
இருங்க, அந்த இருக்கு நேற்று அமிச்சது. இந்த ஒரு நிமிஷம் சார்,
ஒரு நிமிஷம்.
ராமலிங்கம் .prc இந்த ஒரு நிமிஷம் சாட்ல போட்டுருவா. சார் உங்க மெயில் செக் பண்ணுங்க சார், லிங்க் சரிங்க சார். சார் லிங்க்ல இருக்காங்க சார். வரல சார்.
gmail.com.
ஜிமெயில தான் சார் செக் பண்றாங்க சார்.
செக் பண்றாங்க சார்.
சொல்லுங்க. சரி, ஓகே. சரி, கொஞ்சம் 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 வெயிட் பண்ணுங்க. எதிரே வாங்கிக்கலாம், எதிரே வாங்கிக்கலாம்.
ஸ்பெல்லிங் கரெக்ட் தானே சார்? RAMA
GAMலாம் கிடையாது. GAM நம்ம அந்த P மட்டும் தான். LINக்கு அப்புறம் P. RAMA LINP
GAM.
சார் இந்த இப்போ புதுசாக இன்னொரு மெயில் ஐடி கொடுத்துருக்கேன் சார், அதில் கொடுங்க சார். சார் கணிங்க சார். வந்துருச்சு வந்துருச்சு சார். உள்ள போய்
புதிய லேப்டாப் எடுத்துக்காரு ஷான். உங்களுடைய மோட்ல படம் லைட் எக்ஸ்ட்ரா இந்த லைட்டே
சாருக்கு வந்து கொஞ்சம் கனெக்ஷன் சுத்திக்கிட்டே இருக்கு சார்.
ப்ரெசென்ட் பண்றதுக்கு ஒரு டைம் ஆகுது, அதுக்குள்ள நீங்க இருக்க வேண்டியது. உங்களுடைய நெட்வொர்க் என்ன இருக்காங்க
சார் ஆரம்பிச்சாங்க.
சரி அது கனெக்ட் ஆகிடும். அது இல்லாமல் உங்கள் பவர் பாயிண்ட் ஓகே ஓகே பென் ட்ரைவ் மற்றதெல்லாம் முடிச்சிடலாம்.
சரி
நீங்க ஏதாவது கேட்கலாம்.
தள்ளி கொடுத்துட்டுமா?
Yes, sir. I'll make it.
சார் ஸ்டார்ட் பண்ணலாமா சார்?
Okay. Sir, most welcome, sir. I'm Arul Rayavan.
சார் உங்கள்கிட்ட தான் பேசிட்டு.
ஹலோ,
Hello, sir. Most welcome to the.
குட் ஆஃப்டர்நூன்.
Good afternoon, sir.
தேங்க்யூ.
Start பண்ணலாமா?
ஹலோ, ஓகே. ப்ரொஃபசர் அருள் ராயப்பன்
Yes, sir.
பார்த்துருக்கீங்களா என்ன?
Sir, நம்ம இதுல 175 years function timeல மீட் பண்ணோம் sir. He came to the department.
75th
175th celebration. Yes, sir. We came with your friend.
Okay, we will start now.
Dear professors, may I have your kind attention please, as we are about to begin Physics Association inauguration. Honorable guests, dear faculties, and my dear students, a warm good afternoon to one and all. On behalf of Department of Physics, it's my pleasure to extend a cheerful welcome to you all. Your presence makes us very happy. Excellence is not being best. It is doing your best. To begin the auspicious occasion, let us pause a moment of silence to invoke the Almighty.
உண்மையே நன்மை செய்வதா வருவாயா இறைவா?
நாதம் ஈதம் மொழி வேதங்கள் தேறிய குழந்தை நாதம் வேண்டும். சமத்துவம் அன்பில் ஆளும் மலர்ந்திடும் குழந்தை நாதம் வேண்டும். பகை மற்றையமை சீரிடும் மரியா குழந்தை நாதம் வேண்டும். மன்னித்து மறக்கும் மண்கொண்டை பொன்னீர் குழந்தை மனம் குழந்தை மனம் இறைவா குழந்தை மனம்.
ஒரே நெட்வொர்க்ல போட்டுக்கலாம்னா சரி.
அதான் சார் இன்கல்ல இதில் தான் சார் யாரும் இதில் வரல.
சார் சார் தினகரன் சார்.
Okay, sir. To formally welcome the gathering, now may I invite Dr. A.J. Clement Nurdraj, Physics Association President and Assistant Professor of Physics, to deliver the welcome address.
Respected head of the department, staff members of physics department, coordinator from shift 2 and dear students. Very good afternoon to all. As you all know, we are here today to inaugurate our physics association. Today is the day, the World Education Day. So in this regard, in this time here, I welcome Dr. I. Alrayapan, head of the department. His efforts have been instrumental in helping the department attain height of success. I welcome our illustrious alumni, Dr. Ramalingam Periyasamy, Associate Professor of Engineering, Physics and Geology, American University of Iraq, Suleimania. I welcome the staff members of Physics Department. I welcome Dr. G. Samuel, Coordinator of Shift 2. I welcome all the students. I hope all are safe in your places. This academic year, we start the inauguration function of Physics Association through Google Classroom due to the COVID-19 pandemic. This academic year tentative plan is to conduct meeting once in a month, conduct 4 club activities. So in this regards, I request the club coordinators, Fabrication Club, Dr. B. Kanikiraj, Innovation Club, Dr. P. Kristuraj, Einstein Quiz Club, Mr. S. Dominic, Fineman's Problem Solving Club, Dr. R. Gerald Vijay, kindly conduct the activities regularly and motivate the students. To conduct 3 endowment lectures this year, namely Dr. APJ Abdul Kalam Endowment, Dr. S.T. Rajan Endowment, Reverend Dr. G.S. Savri Rajan and Professor S. Anthony Raj Endowment, and we will have one more as per the instruction of college. So this is the plan of our department. I request all the staff members and students to give your support and cooperation throughout this year. Once again, I welcome all to this academic program. Thank you.
Thank you, sir, for your kind words of welcome. If your action inspire others to dream more, learn more, do more, and become more, you are the leader, says John Quincy Adams. At this juncture, I would like to relate this proverb to our head of the department, Dr. I. Arul Rayappan, Associate Professor. His valuable past makes an important today, and it significantly influences on the future generation. May I invite Dr. I. Arul Rayappan, Head and Associate Professor, Department of Physics, to deliver the presidential address. Welcome, sir.
சார் மைக் அன்மியூட் பண்ணுங்க சார்.
Sorry. Excellence happens not by accident, it is a process. Dr. APJ Abdul Kalam. Respected Dr. Ramalingam, our alumni, respected professors, our UG professor Dr. N. Ravi, Controller Dr. Cecil Raj, Substitute Coordinator Dr. Samuel, and all the physics faculties, students, very good afternoon. I am happy here, even this pandemic situation, to be a president of this inaugural function of Physics Association. Physics Association is one which is having its own long tradition. Of course, Physics Department itself is having its own tradition. And Physics Association plays a lot of roles in giving information to the students. Normally, professors will deliver good amount of information, not only pertaining to the syllabus, other than the syllabus also professors will deliver. But if the professors want to have a unique one of his own interest, then we need a platform. That is our Physics Association. It is not only for our physics faculty, the eminent people like our today's guest, Dr. Ramalingam, to come and mingle with us. This Physics Association is one of the important forum. Here, we are not taking the eminent people alone. We are taking our students also as a part. Any student of our physics department can come into the association and they can use the platform what they want to share. And that we are having our alumni too. We have our own students, seniors, super seniors, and grand super seniors, and all are linked into the physics department only because of this Physics Association. And thus, today we have our guest, Dr. Ramalingam, with us. We welcome you, sir. We thank you for accepting our invitation to join with us on this day. Dr. Ramalingam was our alumni. He did his PUC and undergraduate from 1977 to 1982. Then he went on university for his post-graduation, and his profile is a very lengthy one. Dr. Ravi will join with us to have that sharing of the profile. And thus, we are having a pleasant day here to hear to Dr. Ramalingam. This today's situation, material science, is one of the very promising research area. For any of our activity, the experimental as well as theoretical material science is important aspects, especially in the field of laser, fiber, and sensors. Now it plays a vital role. Almost every day, new research innovations are coming up. Today, we are linked with one another only because of this internet. This type of internet becomes possible because of this good optical fiber. This optical fiber plays a major role in material science. It's a product of our material science there. We are having a good optical amplifiers rather than electronic amplifiers. We are having good optical amplifiers, EDFA and all. This type of material side is most essential. Today's our guest is going to deliver a lecture on this material science, one of the frontier area. So I welcome all the students to take part in this and benefit out of it. And I wish Dr. Clement and his team to have a lot of sessions and motivate the students and enlighten the students through their association activity. As well as I wish all the clubs to do much more work than last year. This year, even the pandemic situation, it may be helpful to the students. To give more time to our guest, let me take a leave. I invite Dr. Ravi to share his lengthy profile. Thank you, sir. Dr. Ravi.
Yes, sir. Respected chief guest,
Yes, sir, you are audible.
the clash of this.
Mailar go ahead. Ravi can go ahead.
Okay. Respected chief guest, Dr. Ramalingam, Professor Arun Raipan, Head of the Department of Physics, Professor Alfred Cecilraj, Controller of Examinations, Professor Clement, President of Physics Association, Professor Samuel, Coordinator, Shift to Physics, esteemed professors, and my dear student friends, very good afternoon to all of you. Yes, I am happy to introduce Chief Guest of this program, Dr. Ramalingam. Dr. Ramalingam, working as Associate Professor of Engineering, Physics and Geology, American University of Iraq, Sulaimania. He did his master's degree from 1980 to 82 at University of Madras, Chennai. Then he finished his master's degree in lasers and electro-optical engineering at Anna University, Chennai. Then he did his diploma in analytical physics at University College of Swansea, United Kingdom. He completed his PhD at the University of Wales at Swansea in the year 1989 in the area continuous wave tunable metal vapor lasers. Above all, he did his PUC and BSc in our own St. Joseph's College. Coming to his academic awards and honors, he got Faculty MPRS Rice Travel Research Award in the year 2007 at Alabama on fiber optics. In the year 2007, he acted as a co-organizer of MSIP workshop at Albany State University on cell molecular and forensic sciences. He worked as a coordinator at the Georgia Academy of Sciences meeting in the year 2006. He got Faculty Award at the University of Alabama in the year 2006. Commonwealth Scholarship was granted for him during 1986 to 1989 by Commonwealth Universities, United Kingdom. Regarding the publications, he published more than 12 papers in the internationally reputed journals. Also, he published 13 articles in the conference proceedings. Coming to his research grants, he received research grants from NATO, ICTP trustees, NRC Ottawa, National University of Singapore, IIC Bangalore. Coming to his professional membership, he is a professional member for American Physical Society, American Association of Physics Teachers, Society of Photonics Engineers, Institute of Physics UK, and Chartered Physicist Institute of Physics. Such a high-profile genius is with us. Please give a big hand to Professor Ramalingam. Thank you.
Thank you.
Thank you, sir, for your nice words of introduction. No person was ever honored for what he received. Honor has been the reward for he gave, says Calvin Coolidge. It's a time to honor our chief guest. May I request Professor A. Patrick Prabhu, Associate Professor of Physics, to honor the chief guest with a shawl. Thank you, sir. Now may I request Dr. A.J. Clement Lurdraj, Physics Association President, to honor the chief guest with a memento, a token of our love.
Thank you.
Thank you, sir. Now the most awaiting event of the program. May I invite Dr. P. Ramalingam, Associate Professor of Engineering Physics and Geology, to deliver his lecture on the topic Frontiers in Material Science and its Application. Welcome you, sir.
Thank you.
Screen share போட்டு விட்டு.
Hello, good afternoon. Can you all hear me? This is probably my second. You can hear me all?
Yes, sir. Yes, sir.
Yeah, okay, thank you. Okay. Now today I'm glad that I can talk to you academically on some aspects of material science, its applications in everyday life. First, I would like to start off with a few words of motivation. So if you look at my my own profile, just a minute. So you can see I come from the Mars or any other place. I just come from Tirchi, and I studied in Tirchi and did my schooling in Tirchi at St. Joseph's. And all I can say is if I can manage all these in those days, that's about 30 something years ago. In modern days, you can also achieve the same. A person from Tirchi can travel around the world and perform academic duties and be helpful to the entire community. You can also do that. I have built in my time lasers, especially nitrogen laser, carbon dioxide lasers, and metal vapor lasers like copper vapor laser and helium cadmium ion laser. The helium cadmium ion laser is the laser. This is called a work light laser. It is versatile in using color schemes in those days, and also for medical imaging. I did complete my PhD in 1990 from UK. I immediately joined postdoctoral research at Queen Mary College, London. It was quite easy to find postdoctoral work as soon or even before you finish PhD. I was also continuously doing research work on Raman spectroscopy at the University of Leeds. It was under collaboration with two universities, with the two companies, British Aerospace, as well as the British Petroleum. These two firms supported my research. Now I will explain why these two companies contributed to my research in the later part of my talk. You'll come to know this. As a part of my thought and philosophy, I did in a lot of different parts of the world, especially in US. And as a job, I went and studied university in Africa, the American University in Nigeria and Africa. A bunch of 100 different faculties from US went to Africa to start this campus, which is still running with 6,000 students. We have to also make sure that the African continent is also part of our development platform. And later on, I also came back to Iraq, the northern part of Iraq, which is the most persecuted of the region in Iraq under Saddam Hussein. So we lived and built a university in the American University of Iraq, which is in the northeastern part, closer to the Turkish and Iranian border. This university is also currently running with about 3,000 students. So my period, I've taught more than 4,000 students, some of whom have already completed PhD and are now started their own entrepreneurship work in US. That's my introduction. Now a few words in my next slide. If you go, you will see the Indian physicist. He's also born in Trichy, so I'm just trying to motivate you guys. Not that being in Trichy or living in a small town, you can be in Trichy and you can still grab the entire attention of the world. Sir C. Raman got the Nobel Prize for his discovery of inelastic scattering of light way back in 1930. In those days, we were still under British rule, so he was also knighted by the royal, the Queen of England. There are other Nobel laureates. The cousin of Sir C.V. Raman is Dr. Subramaniam Chandrasekhar. He also got a Nobel Prize in Physics. He started his research at the University of Chicago, where massive stars can collapse under its own gravity. The stars, when they are about to die, will try to expand. Heat inside, the thermonuclear reactions that is happening at the core. And as they started to expand, they sometimes expand too much that they started to collapse under their own gravity. So his research gave this how stars collapse. And for his contribution to astronomy, the International Space Station has an X-ray machine or X-ray telescope, and it is named after him. It's called the Chandra Space telescope. It's on the International Space Station. We also have Dr. Venkatraman Ramakrishnan. He also got the Nobel Prize in chemistry for 2009. So you can see a lot of people are from Tamil Nadu, did get Nobel Prize. So we should also be very proud of all the people's achievements. So this is just sort of a motivation for you to start looking for ideas. Now, my outline of my presentation is to introduce novel materials. Novel means new materials. Why do we look for new materials? As you know, the main aim of scientific community is to alleviate the problems of the society and try to give some innovations so that their lifestyle, their way of life improves. And this is how the system evolves and people get more and more comforts of life because of science. Now you all know that you are using cell phones to access this. The cell phone is made up of materials, and the material that is inside is a silicon material. And you can understand how silicon materials are captivating us as well as become ubiquitous. That means without it, we cannot be living. So we will be talking about the applications of materials. We also know, I mean, many of you know what's a laser. Huh? Oh, sorry. Sorry, we are getting back to you. இதில் ஸ்க்ரீன் போட்டிருங்க இதில் நீங்கள் அதில் பார்த்தீங்கன்னா அதில் மாற்றிங்க. Okay. All right, we'll get back to the my outline of my presentation. Introduction to new materials. Why do we need to look for new materials? I already told you that we are in the process of trying to solve the problems that every now and then we come across. How to alleviate common man's problem, modern technology. And we will also look into applications of such materials. You will get to see at the end of the slide. What's the laser? You all know laser is light amplification by stimulated emission of radiation. Laser was invented in 1960. Computers were invented even before that. So you know computers are revolutionizing the world. So the time for laser to revolutionize is still yet to come. So now is your chance to try and think of how to use a laser rather than in solving various problems. Laser is ubiquitous. We will talk about laser spectroscopy. Thank you. The next slide, we see a structure of graphene. Now, graphene is, as you all know, is a modern nanomaterial. In this graphene, you see sort of a hexagonal structure where carbon particles. As you know, carbon particles, they have about 6 electrons, the 2s, the 3s, and the 2p. It is only the 2 electrons in the outermost shell that contributes to the conduction. So whenever you're using graphene as a conductor or as a superconductor for computers, we are looking into the outermost electrons, the 2 electrons. The next slide. This is also another new material, titanium. Titanium is also second hardest material next to diamond. Diamond being the hardest material. Titanium is also used in hip joints. Majority of people who are in Western countries who are old, nearly half the population would be either having a knee joint or a hip joint. The hip joints have to be balanced in such a way that they can mimic the normal movement of an ordinary person. So the hip joints, as you can see, will have its own wear and tear. So you have it as lightweight, but on the other hand, it has to have a high strength, and you cannot be replacing knee joints every now and then. So it is once fixed, it has to be there until the person's lifetime. Next. Now, the tip of the hip joint that you saw has a polymeric base, because on the polymeric base you can have the synovial fluid that comes in, which helps to lubricate. Ultra high molecular weight polyethylene oxide has been used as the hip cup material for 30 years, and it has been given good results so far for prosthetic limbs. And a continuous study has been done on simulating movements, and increased research has gone in to see whether they are compatible with the physical movements of the people. So polymeric materials are inert, and they have passed a lot of tests regarding chemical biocompatibility. Unfortunately, there is also a lot of problems with these, because polyethylene also degrade, and once they degrade, they also flake, and then they also. Another type of material is we want the high thermal resistance materials. So here you can see this is only 5% wood. The rest of it is foam, which is polymer, and is less dense. That means it's less in weight, and it forms the inner lining of most of the aircraft. So the aircraft can be, and also the inner. We also come across hydrophobic materials. Hydrophobic materials, yeah, I guess all of you would like to have or would have seen computers which are, or phones that can be working underwater. So you have seen advertisements of phones being dropped into water and still working. So because they have hydrophobic coatings on top of them. Some applications for everyday person is what you see here is nitinol, which is nickel and titanium, which is a type of ceramic. Now it's even the teeth can be replaced with a ceramic material. In those days, people used to have either a gold tooth or a silver tooth. Now you don't need to look for a mold of gold or silver. You can just use a replacement using ceramics, which is easy to mold. Here I show you two pictures. You can see the left-hand side picture. The fixation, the brace is not visible. Whereas on the right, which is what people used to wear in those days, which is has a tight metal guard, which sometimes constricts or causes uneasy in the movement of your jaw. In comparison, the left-hand picture is more convenient. So this is one use of new materials in dentistry. Other smart materials, as you can see, are shape memory alloys. That means the alloys, they shape and they go back to their original state once their stress is relieved. As you can see, there is a picture at the bottom, which is a spectacle frame. There's also other polymeric materials like thermochromic polymers, which changes colors. depending on the temperature outside. Now, such materials can become very good in the case of buildings, because sometimes you want the building to reflect as much sunlight as possible in order to make the building cooler. Photochromic polymers are reflecting. Photochromic polymers are sometimes coated on top of windows, the glass windows, so that they block the UV light. So the UV is the one that causes heating inside the building, because UV light comes in and it gets trapped and causes IR, and it gets what is known as the global warming. We also have quantum tunneling composites, and I will talk about that. One of that composite we just now saw. There is material which certain sections of it becomes a conductor, whereas on a transverse direction it becomes an insulator. So quantum tunneling composite is an insulating rubber containing tiny particles of metal. When squashed, the materials allows current to flow. The earlier picture that I showed you about the graphene is also similar to that. The graphene that you saw is conducting, is superconducting. But the same material, if you twist it by a 70-degree angle, becomes a non-conductor, becomes insulator. So this way you can use it as a binary switch. Other smart materials you can see: body armor, bulletproof vests, Kevlar suits, and you can see the person wearing gloves. The gloves is you can use the gloves and you can still operate your computers, your cell phone screen, because the touchpad micro switches on the gloves. So in cold climate, you don't need to remove the gloves to operate your phone. So you need tiny micro switch power tools. There are other composite materials which you have widely seen. Composite materials are mainly they are rugged, they are easily changed into shapes, and their material properties changes. The main thing that we are looking for is their durability as well as corrosion resistance, resistance to environment, etc. So here we talk about combination of natural and synthetic materials. Fiber-based composites, we will see what it is. Particle-based composites, which is concrete. In a concrete, those days they had only cement, sand. Nowadays, to the cement and sand, they add some other polymeric materials which increases the shear stress, the shear strength of the material. That means when you bend the material, it can absorb the stress and not have cracks developed in them. And then sheet-based composites, which is plywoods or even carbon fiber material. Fiber-based composites are reinforced with fibers, and some of these fibers, they also nowadays are being used by a company called 3M. You know 3M from those days. They used to make floppy disks and floppy drives of magnetic materials, but nowadays they have come up with materials or films which can be coated onto aircraft blades or aircraft wings, the body of the aircraft, so that when there is a wind gust, these fiber materials, they try and deflect, because they have sharp edges on top of them. They try and deflect the wind gust so that the structure doesn't get damaged by the wind gust or any other damage or fatigue. They call it fatigue. It means the material gets fatigued due to consistently being hit by high force winds. We have glass enforced plastics, glass fibers and resins. We all know we have chairs. Nowadays we have the molded chairs. which are made of glass fibers. We have resin boats, the modern day luxury boats, and then instrument cases. All these modern electronic gadgets, they come with instrument cases which have reinforced fibers on them. We also have carbon reinforced plastics, but is still only in the the circuit car races only, not for commercial cars because it's too expensive. And also glass reinforced concrete, glass fibers and concrete. So it's like street furnitures, other things. So these are things that you can always learn. I'm going to talk about the same fiber optic material fiber which can be used, an optical fiber which can be used sensor. So here you see a modern bridge being censored because we have a fiber optic material. Fiber optics, there is a fiber which is a silica fiber, and it has a core and a clad. Both the core and the clad are made of the same material but of different refractive index. And because of the phenomena of total internal reflection, light passes through it and comes out at the end. If the same fiber is subjected to a stress, then what happens? Some parts of the light may not come through the other end because there is leakage, because refractive index of the material changes when there is refractive index of the material changes, so there is a loss of intensity light. Just a minute. So here you can see points 1, 2, and 3 are places which are shown separately in the pictures down, where the sensors are mainly maintained. This is just optical fibers stretched out and placed, and you shine a laser light through them, and then you look for the output light at the other end. Based on the polarization or the intensity of the light, the phase of the light, one can determine whether the building is under stress or the structure, the bridge is under stress. So this is a picture of the inner of an optical fiber, which is what nowadays brings you internet connection. You all heard of fiber optic telecommunications. So this is, and also fiber optic televisions, etc. So optical fiber, the picture on the right shows you laser light passing through it, then goes through this bundle of fiber and comes out. Now, if the intensity of the light at the other end, or the polarization of the light at the other end changes, then obviously the fiber is being subjected to some level of stress. So the light that passes through the fiber is subjected to a change in intensity, phase, polarization, or sometimes even wavelength or the time. Hence, this can be used as a non-destructive method of testing, because in those days people used to run a roller on a bridge to test the strength of the bridge. You don't need to destructively test a bridge for it. You can do it non-destructively. This is a little bit deeper into the same sense I talked about. If you are interested, I can go through. Otherwise, I will just glancingly pass through it. You have a laser light passing through a fiber. The fiber is shown in the middle. That's the okay. So this is the optical fiber. So you make sure that the fiber has a certain polarization orientation. So you use a halfway plate, and it is coupled. So here you have to make sure that the fiber, the laser light is oriented in one direction. Electric field and the magnetic field are oriented in the one particular direction as they go into the fiber. Now, due to a stress in the fiber, that is the stressing element. The thing that the light that comes out has a different polarization or slightly changed in polarization, one can identify where exactly the stress is being subjected, and one doesn't need to go along the entire length. One can precisely detect the specific portion and then try and attend that particular area. So this is, as you know, laser light itself is polarized, and you can use a half-way plate to rotate it to one particular polarization. This is what is known as polarization-based sensor, where fiber optics is used to monitor structures, building structures as well as industrial structures. And in later use, it is also coming even to commercial home uses as well for these things. So other types of fiber optic sensors. We have physical sensors. We just now saw what's a physical sensor. You can also use it for measuring stress. You can also measure the stress from the polarization data. Chemical sensors where pH, gas analysis, and also spectroscopies. Biomedical sensors where we need to know about the body physical parameters like blood pressure, flow of blood, the viscosity of blood lets you the flow of blood. The body blood has enough sugar in it, the viscosity increases, and so does the flow. So blood flow, glucose content. On the glucose content, I'm going to go a little bit deeper into it. So we'll wait for that. A typical application of the same fiber optic sensor for stress is also where we look for these modern fiber materials, textile materials. They depend on how they are being stretched. If you stretch the material too much, then it snaps, then they have to make sure that they have to switch off the machine and then correct it. So they have sensors to make sure that the yarn or the material that is used for making a fabric not being stretched too much. So it is being stretched to the right limit, so the stress level it can handle. So here I can show you the pictures of some of the fiber-based sensors. They are also known as fiber Bragg grating sensors. That means the same optical fiber material that you saw earlier, sections of the optical fiber have been modified. They have been sculpted so that the refractive index changes periodically in them. So you expect a certain result from it all the time. And if there is a change, then one also knows that there is a stress there. So this one also you can have. This is still in the initial stages. So one can also develop a lot of time studying this. Extrinsic type sensors. This is where you are looking at the intensity of light that comes out. And one should automatically know when I talk about light passing through the LiPo and the light that is coming out at the other end. This is an area where which is increasingly important, especially in the biomedical area. And one such area is known as surface plasmon, where you have gold nanoparticle with certain material antibodies coated on top of it. At the moment these materials are placed inside your body, and if there is an analyte that you are looking for, like coronavirus or some other bacteria that is going to be in your body system, they will be attached to this because they have an affinity towards them. So the hydrogen ions, we attract them, and these radical elements are being taken out of the system. So that is extrinsic type 1. One such the picture of the intense geometry fiber is shown here. You can see there is a bending. So wherever you see the bending, wherever you see the bending, these areas you see the intensity of light being lost. The intensity of light that is being coupled here is not the same intensity of light that's coming out. So obviously one knows that the fiber is being stressed at two different places. So those are some of the uses of extrinsic type of fiber optic sensor. So one can use this for structural health monitoring. One can, the main advantage of this is you don't need to have electromagnetic interference, because often microwave communications and telephone communications, they have a lot of electromagnetic interference, whereas fiber optic signals, they don't come because there is no electromagnetic signals. Corrosion resistance, and this is also cheap. Fiber optic sensors are quite cheap because the material there is pure silicon, and it can be embedded into a system without causing anything. And as you can see, there is other advantages. There are bound to be certain disadvantages. So that's where the research stages are still going on. So one needs to look into all these. The main advantage of a fiber optic sensor, one fiber optic sensor can be used for monitoring or detecting multiple parameters. So you don't need to use one fiber optic sensor for temperature, one fiber optic sensor for pressure, one for pH and everything. One can use the same because they have a large bandwidth. Optical bandwidth are 10 to the power 14 hertz, whereas microwave is only 10 to the power 6 hertz. So you can see that there is at least 100,000 advantage. And moving to the next slide, this is an area where I like to spend some time. Almost majority of the population that you all know, they have diabetes, or type 2 or type 3 diabetes, or type 1, sorry, diabetes. So diabetes is when the blood sugar level of your body changes because of the amount of insulin your body produces. So how to detect a person's glucose level or blood sugar level? You would have already known that most of the people do prick their fingertips every day, at least twice a day, to check their blood glucose level. Although that may not be a very nice method, because you need to prick your body every day, and then you have to take at least a drop of blood every time that you do that. And it's also quite time consuming and costly for some ordinary people. So how to detect glucose here from a human tear? From a human tear, how can one look for glucose sensing? So tear glucose sensing, this has been still in the early research stages. What is happening here is a photonic crystal. Okay, these are also known as colloidal crystalline array. So this is a non-invasive monitoring of glucose in human tears is highly desirable, where glucose need to be controlled. So the contact lens could be coated on the inside. People do wear contact lenses. Even if they don't wear, you can have a contact lens and you can coat these polycrystalline colloidal array on the inside of it, and then the person can mount the contact lens for a small period of time. Based on the the amount of teardrop that is there, the glucose could be easily detected. So the near-infrared PCCA comprising of glucose response, sub-micrometered polystyrene, this whole thing, which I call it boronic acid, they a slightly positive hydrogel. So this is the backbone of the CCA, on which you have another matrix of polyacrylamide, which is coated on top of it. So this is the actual signal element that is actually going to signal the glucose. This is just the base. It's the substrate, you can call it. So this newly designed near-infrared PCCA can reflect near-infrared light, usually at 1722 nanometers, and the intensity of the light decreases, evidently with the increasing glucose concentration and from the range of tears. One can see the glucose concentration currently that can be monitored is 6.1 micrograms per deciliter, which is fairly accurate. And based on other things, it is also has a sensing time of 22 seconds. So you don't need to wait for 2-3 minutes. It's only 22 seconds that one has to wear the response time and the scalable limit are pretty much very good indicators that this can become a modern day machine for everyday use. So such a rationally designed is well suited for sensing, especially for older people if they are they can't be subjected to the hospital trip every day. So they wear this, and then from the tip one can see the change in the color. I'll show you the picture one more time. I think I was in the right place. As you can see, this is the one that shows you. Okay, this is the indicator. Okay. So this indicates where the glucose level is. So I did some study on this, but not necessarily for glucose sensing, but this is the experimental arrangement that I used. This is the nanomaterial that I use, which is polystyrene nanomaterial. This is just the base material. So as you can see, polystyrene material, when you lay them out, they sort of self-arrange themselves. And you can see the neat arrangement that they have. And you can see the and there are about 7 or 8 particles in between. So one can say that each and every particle is about 200 to 210 nanometers. Okay, so the details of this is a commercially available nanomaterial, and this can be used for sensing materials. You cannot use this material itself. You need to add a certain optical material on top of it. So I used this material as a type of a sensor, especially as a pH sensor. Now these are my earlier results that I did, and you can see that the material, all these materials, that the nanomaterial that you know, the outermost part of it is electronically negative. So they tend to repulse each other. But then there is each of the materials, they have a nucleus. So due to van der Waals attraction, they do come together. So there is a sort of a balance between the van der Waals forces, which tries to keep them together, and the Coulomb's repulsion force, which tries to keep them away. So whenever you have a pH means you bring in more hydrogen atoms into it, so positive. So you can see there is bound to be some sort of a arrangement. The atoms, the colloidal particles are supposed to change. So this is what you see here. So this is for the lowest pH. That color I can see is pinkish in color, which is over there. And as you can see, the blue one, which is 6.77, the light, the emission light or the Bragg reflection light that comes out, or the reflected light that comes out, is being shifted. And the shifting, we have found out that the shifting for different pHs has been quite linear. The amount of shift tallies with the amount of pH variation. So this is still in the experimental stages as an instrument to come for future uses. So once again, this will become a reality. The teardrop thing will become a reality if research going into this area is has been proven. Of course, there are some sort of disadvantages that we are still facing because it's all colloidal crystalline array. They tend to break down, so one needs to look into other aspects of maintaining them for commercial use. There are other types of biological sensing. In those days, they use biosensing. The people who go use work in the coal mines. The coal mines, you have to go 2-3 kilometers deep under the ground. So they used to take a canary bird, so when the bird dies, then they know that the amount of carbon monoxide poisoning is there, so they come out. So that is not a very nice way of testing, but then that is the biosensor that they had in those days. So nowadays, you don't need to go resort to that way of testing. So one can use, one needs to look for biosensors. The detector can be a tissue, a microorganism, or an enzyme, or an antibody. In the case of coronavirus, we are looking at a certain protein antibody, which is going to be the indicator, what is called the monoclonal indicator. Once again, interacts with the analyte and it will convert into a signal that it can be easily measured. So one can see this technology combines a lot of disciplines: chemistry, physics, biology, and electronics. So you don't need to physically stick to physics. I would expect you to throw your time into other areas and look for avenues where you can go look for your own way of try and see where you can contribute modern day technology to something that you can take to ordinary people. So the current day technology, one can look into food like food contamination, counterfeiting of medical drugs. There's a lot of ways where one can use technology and biosensors. Medicines nowadays, they are fake medicines. So most of them have lost their efficacy because of their poor storage conditions. But just because you take a medicine, you cannot expect that you can live longer because you've been eating adulterated medicine. So these are areas where one has to look for these modern day applications to enter. So with that, I think we come to the conclusion part of this thing. I was having a few other slides, but then I think Oh, I tried to tell you about the two people who tried to complete my research when I was working. Those are the British Petroleum. The British Petroleum, they had whenever you have petrol in your car, it gets into an accident. The first thing that happens is to protect the fuel of the vehicle. That is why aircrafts, whenever they get into some sort of a difficulty, the first thing that they do is they dump the fuel. So all the fuel is being lost. So because fuel, whenever it comes in contact with oxygen, they become flammable. So it can catch fire. So polymer additive has been there in concrete in order to increase so that they can absorb the stress and then make sure that the build can last longer. So polymer additive that enhances physical performance. And here we are talking about metakaolin. This is a market name. This is a market product, and it can be added into cement and used in commercial. And once they are placed on top, they can reduce the amount of cement that you are going to use. On the other hand, they can absorb moisture into the, whenever there is a moisture, they can absorb and then try and make sure that they don't corrode, the material doesn't corrode. And they give you good shear strength and compressive strength. One last slide, I think we are out of time, is the lubricants. People do change engine oil and on a quarterly basis, at least 3 or 4 times in a year. And all these lubricants, they once again are very harmful to the environment because they have to dump them. The engine oil is mainly to cool the engine. The engine oil is lubricant. It removes the heat from the heat engine or the internal combustion engine. And the basic property of the lubricant is its rheological parameters, the viscosity. Whenever there is the viscosity, you would have seen at home when you cook something in oil, you cannot use the same oil forever and ever. So once you cook 2 or 3 times a fried food like a bhaji, you have to throw the oil after 2 times because it has lost its the polymers or the organic materials have lost the parameters, the heat capacity. Elongational viscosity, when they are subject to shear stress, they break down. So that's why one has to keep changing lubricants. But on the other hand, if you can add some polymers to it, and these polymers can take care of the elongational stress as much as possible, so that the oil can be used for changing once in 3 years, you can change once in a year. So this will be an enormous advantage to the environment. So one can sustainably develop using this. And such type of additives are not too much. You're adding like 1 kilogram of the material, you're adding 0.1% or less than 1%. And such additives are even added into the food processing industries in order to put the texture of the ice cream, the smoothies, and the milkshakes. Okay, so with this, I think I come to the conclusion that modern day materials have a great level of research still need to be done. There's a lot of research needed. A lot of universities still have a lot of opportunities for you waiting. So I hope you get motivated and try and concentrate on what is known as a more digestive learning. You learn what you're going to do. You have to cultivate a passion for the learning, so that learning, not only your family gets to enjoy or relish, the society itself in general gets to experience it. Thank you very much and thank you for the opportunity. And I hope you will have some questions and I will be happy to answer any of them. I will pass on to Dr. Cecil Walsh. So, once again, if you have questions,
Dear professors, the session is open for discussion. If you have any clarification or any doubts, please discuss with the guest.
you can ask questions on anything, not necessarily on the topic, even about myself. If you are looking for postgraduate opportunities, where to study, how to prepare, when to start preparing, can I go after my BSc, how much would it cost?
Okay, thank you, sir, for your motivation. A very thought-provoking.
Thank you. You can always pass on any questions. You can also pass on any questions you may have in email link.
Okay, thank you, sir. Thank you, sir, for your motivation. A very thought-provoking and a really insightful presentation. Your thoughts are going to stay with all of us. Once again, thank you, sir.
Thank you.
We are now at the end of this inaugural function. To give a perfect end, I would like to invite Ms. F. Selin Hemalada, Assistant Professor of Physics, to deliver vote of thanks.
Good evening to one and all gathered here. It gives me great honor and privilege to propose the vote of thanks on this memorable occasion. Let me first of all start by giving glory to the Almighty God for making today's occasion a resounding success. First and foremost, I thank our special guest, Dr. Ramalingam Periyasamy, Associate Professor of Engineering Physics and Geology, American University of Iraq, Suleimania, Kurdistan region, who despite his busy schedule has found to grace this occasion. Thank you, sir.
Thank you.
We are grateful to Reverend Father Secretary, Reverend Father Principal, for the words of encouragement towards the department. My heartfelt thanks to beloved HOD of Physics, Dr. I. Arul Rayappan, for his valuable contribution, guidance, and encouragement in all our efforts. His able guidance has always encouraged us. Thank you, sir. I owe special gratitude to our association president, Dr. Clement Lourdraj, to make this occasion a memorable success. Thank you, sir. I thank Dr. B. Kanikeraj for his technical efforts, and I thank Shift 2 coordinator, Dr. G. Samwell, for giving me this opportunity. Last but not the least, I thank you, my dear professors, for your cooperation in making this inaugural function a grand success. Once again, I thank you all for your attention. Thank you.
Thank you. You come.
Vinaran, you can switch on your mic. Unmute.
Thank you, ma'am. Thank you all.
Thank you, sir.
Thank you all for spending time with us today. I hope this lecture is informative and is useful for you. Thank you once again.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you for all. Sir, Dr. Ramlingam, sir, thank you very much for coming with us to give
Thank
a
you, thank you.
lecture to you.
I
Yes,
wish
sir.
your association will have a lot of activities this year.
Yes, sir. And some more time after this pandemic, if we spend time to share how to take our students for some broad study research and all, what university we can select such a way.
Sure,
And
we
the day
can.
when we are in the department also, you highlighted those points. And such guidelines may be helpful to our students to take higher education. Like
Sure, we will certainly.
We
We will also
do a lecture on
invite
it.
some interested faculty also to
Yes.
see if they can write small grants to some agencies and get grants,
Yes, sir.
mainly in the areas of how to take physics to the inner schools. Inner schools means schools inside the villages where they don't have facilities for doing physics experiments.
Yeah.
So you can write up a grant where you bring them here for 2-3 days when they have holidays and show them some experiments and send them back. So this will be a nice way of your school and your college also getting good public outreach.
So some days again we'll come to you to get your time, sir.
Sure.
Thank you very much for giving your time on this day to motivate on various topics of material science. So that definitely for our PG students it will be very useful to think about their higher studies or research. Definitely there. It's a wide spectrum of information you're giving to us. Thank you very much, sir.
Thank you.
Thank you, sir.
MOU we can sign.
MOU you can
MOU வந்து காலேஜுடைய ப்ரொஃபைல்ல கொண்டு வந்துருவாங்க.
you can there is a USA region on it. அதில் வந்து நீங்கள் you can write small grants. This is up to $50,000.